Hello, Math Study students. Welcome to another online lesson. Today we're continuing our unit on logical, symbolic logic, and we're moving forward from what we've seen with regards to basically just terms, notations, and symbols, and now we're going to start doing something a little bit more meaningful with all of those. So today we're going to define what a tautology is, a logical contradiction, and logical equivalence. And then more importantly, we're going to create some basic truth tables. So our goal is to be able to interpret these truth tables for compound propositions. Now these problems can take a little bit of time to do, especially when you're first starting off. So I'm going to give you these terms of notation to start with. I'm going to give you a basic definition of what the truth tables look like, and we'll do one example together, and then the remaining examples on the slideshow we will work on next class. So a truth table shows all logical possibilities and allows for the comparing of outcomes. If two compound propositions have the same true-false column, we say that the propositions are logically equivalent, meaning that they're logically the same. They have the same outcomes. Tautology, very important word. Think of it like the word total. Tautology, tautology. Tautology indicates a true compound statement, generally found when we have all t's representing truths in a truth column. A logical contradiction is all false in the truth column. And the number of rows in a truth column is found by the expression 2 to the x, where x is the number of propositions. So if I'm comparing two things, like a p and a q, well, two propositions, that would be 2 to the second, which is 4. So I would have a total of 4 rows in my truth table. If I have p, q, and r, now suddenly I have 3 propositions, so that would be 2 to the third power, which means I'm going to end up having 8 rows in my truth column. And so those are the terms of notation. Now we're going to start making some sense out of all this. Complete the following truth table. Well, the way you always start off with a truth table is you take your propositions, often a P and a Q, or a P, Q, and an R, 2 letters usually, sometimes 3. And you start off with this pattern. T, T, F, F. That's true, true, false, false. And the reason we do that is because we're going to pair the trues up with the Qs. If P is true, Q could also be true, or Q could be false. So far we have 2 combinations. True, 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 false. Both of these have P true and then the 2 different options for Q. For P is false, now we could have Q be true again, or we could have Q be false. So we have 2 more options, this time starting with P being false and then the 2 options for Q there. And that's always the way we start off a truth table. If we have 3 variables, and you notice that is 1, 2, 3, 4 rows. And that follows the idea that we have 2 different letters. And you'll notice that all these others here are still just using those 2 letters. And that's what I was talking about that last bit on the last slide. You can find out how many rows you're going to have, 2 to the power of however many letters or propositions you have. We had 2 to the 2, which is 4. So we have, 1, 2, 3, 4 different rows going on here. If I had 3 letters, P, Q, and R, I would end up, you'll notice here the Q column, I guess, goes every other one. TF, TF. Well, I will still go TF, TF in the last one. But I'm going to have to do it twice as long. I'm probably going to run out of room here. TF, and then TF again. The Q is going to be more like the P column here, where you went 2 trues, then 2 falses. So I have T, T, then false, false, and then T, T again, and then false, false again. And then last but not least, now I'm going to double up and have T, 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 and then false, 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 and false. So I've got every combination. I've got all trues, I've got all falses, I've got everything in between. And we could repeat that pattern even if there were 4 variables, though we'll never do that in this class. Okay, now let's start seeing what this stuff means. So the next column is not P. Negation of P. So you look back at your P column and you say, what was in there? I had TTFF. Well, this is always going to be the opposite of that, the negation of that. So if it was true, now it's false. The first two were both trues, so now they're both falses. The next two were both falses, so now they're both trues. And that right there is the negation column, negation of P. And I could make another column for the negation of, whoops, I'll just do that again. I could do the negation of Q as well. I just didn't add that onto this one. Again, false, false, true, true. So negation is the easiest one. You just look at what was in the original column and switch it. P and Q. Think back to probability. P and Q meant that, you know, both things occurred. So in this case, in order for P and Q to be true, both P and Q need to be true. So it's like saying, I'm a math teacher and I can fly. That is not a true statement because one part of it is not true. But if I say I'm a math teacher and I work at Reagan High School, that's true because both parts were true. So I look at the first one here, they're both true, both the P and the Q column. So that means I can put a true here. On the next one, are they both true? No. P is true, Q is false. So I put a false down. The next one, I have a false and a true. Well, I need both trues, so that is false. And then the last one, they're both false. Both false. That does not make it true. It makes it false. But that's a very commonly missed one. People say, oh, both false. Well, they're the same, so it's true. No, that's not how it works. It's an and statement. So if I say I'm the richest man ever and I can fly, that doesn't make a true statement. They're both false. My and statement is just as false as anything else. Now, or I need one or the other to be true. If I told someone it's either Monday or it's Tuesday, well, if it was either one of those, then I'm correct. Also, we assume that if they're both true, it's correct as well. So the first one, I've got P and Q both true, so that's true. And the second one, I just have P true, but that's good enough for or. The third one, I have just Q true, but that's good enough for or. The last one, neither is true, that's not good enough. So for or, you need one or the other or both. Now this one, we remember that's our or symbol again, but it's exclusive or, so it's one or the other, but not both. Look at this first one here. That's true, true. That's both. We don't want both, so that's false. The next two here, we have true, false, and false, true. That's one each time, so those are both true. And last but not least, both false, no good. Again, this means one or the other, but not both. So as long as there's just exactly one true, we have true. True, true is no good. Two false is no good. And I think for the most part, a lot of us are like, yeah, that all seems to make pretty good sense. Now we get to the if-then. I'll talk about this more in class, but if-then is, if the first is true, it's saying the second one's also supposed to be true. And that's all it says. If the first one's true, the second one is also supposed to be true. So if we look here, the first one was true. So in order for if-then to be true, the second one also has to be true. And if we follow, the second one was true. So if P was true, Q was supposed to be true. They both were true. So the if-then statement is true. If the first one's true, the second one's supposed to be true as well. Well, in this case, P was true on the second line here, but the Q was false. So that is false. Because again, if-then says if the first one's true, the second one's supposed to be true as well, and that was not true on the second row. Now, what happens if the first one's false? Well, again, think back to what I said if-then meant. If-then means if the first one's true, the second one's supposed to be true as well. Well, this one, the first one isn't true. So, innocent until proven guilty. This is true. Again, first one's not true. Okay, so this is true. It's only false if we can prove it false. And the only way for an if-then to be proven false is to start with a true and end with a false. Seems crazy, I know. I will talk about it in great detail next class. I'll give you some better examples, but I don't want to fill up a video with 10 minutes of me talking about why if-then is that way. But that's the truth table for if-then. Last but not least, we have our implies, our if and only if. Our equivalence, if and only if. I think equivalence is a good way to think about it. If they're the same, like true, true, it's true. If they're the same, like false, false, it's true. If they're different, like TF or FT, it's false. You can also think of it as an if-then going in both directions. So if the first one's true, the second one's supposed to be true as well. And if that works in both directions, then it's true. Same thing with false. If the first one's false, it doesn't matter what comes after. And if that works in both directions, we got it. So anyway, here's a basic truth table layout. You can find this also in your formula packet. This is new this year. You used to have this memorized. Now you do not. But you should still have it memorized. All right, I promised one example, and then we'll do the rest in class, and I'll talk more about the why on the if-thens. I'll give some more concrete examples. But create a truth table for the statement Q or not Q and P. So first things first, look at how many different propositions, aka how many different letters we have. And we only have two. We have P and we have Q. Now we're doing different things with the P's and the Q's, but that's all we have. So I go ahead and I start off my truth table there. If you want, you can already fill in your TT, FF, and then TF, PF. Always starts off the same way. Now look at your, we can only compare two things at once. You'll never be comparing a bunch of things together unless they're all connected with an and, in which case they all need to be true. But for the most part, we're only comparing two things at once. So I'm going to start with the parentheses because that's what order of operations tells me to do. So I look in here. Now, do I know both of those propositions, P and Q? Well, I know P already. I already have a truth table for it, TT, FF, or a truth column, that is. But I still need not Q. So I'm going to make a not Q column. Carried away there. Okay, so not Q. Once I have not Q, I will need to compare that not Q to P using the and symbol. So now I'll just be comparing those two columns together. And once I figure that column out, I'm going to take this whole thing, which is not Q, not Q and P, that whole thing, and I'm going to compare it using this or symbol to Q. And when I've done that, I'm done. And I'm never comparing more than two columns at once, which is my goal. If that went a little fast for you, again, we'll do some more examples next class. So now we've got not Q. I just look at my Q column and switch everything. So it started off true right here. I turn it into a false. Then it was false, so I turn it into a true, so on and so forth. Now I'm using and. Now remember back on the last slide, in order for and to be true, both of them need to be true. Which two columns am I comparing? Well, I've got this not Q, which is right here, this column, and then I've got P, which is this column. So sometimes it helps to lightly mark which columns you're looking at so you don't accidentally look at the wrong ones. Again, in order for and to be true, they need to both be true. So take a look at this first one. P compared to F, are they both true? Nope, so that's false. The next one, I have T and I have T, so that is true. Next one, both false. Do I like that? No, and they have to both be true. And then I have false and then true. I don't like that either. They need to both be true. So false, true, false, false. All right, so now I have figured that out. Again, I'm sorry that my board keeps getting messy because I keep writing all over it. So I'm going to erase my stars that I had. And I will do the last column here, which is going to compare this stuff in parentheses, which we just figured out. And it's going to compare the Q, which we have all the way back here. So I'm comparing the Q with that stuff in parentheses. And it's getting compared using an or symbol. Now remember, or only requires one or the other or both. So basically, if there's any trues anywhere, it's good. It's only if there's all falses that it's bad. So on this first one, I am comparing, I'll use the black marker to distinguish, comparing Q to the stuff in parentheses using an or symbol. So I just need at least one of them to be true, and the Q is true, so I've got a true there. And the next one, I'm comparing this false with this true, and at least one was true, so that's good. Next one here, I have true, and then false, at least one true. But then I get to the last one, and they are both false, or I need at least one true, so that is false. So this right here is the result of the logical argument there. Is it a logical argument? Is it a valid argument? This, we would say, is not valid. Not valid. Why is it not valid? It's not valid because it's not a tautology. I'll save you the trouble of rewinding the video to figure out what a tautology is. A tautology is when they're all true. If they're all true, it's a valid argument. If they're not all true, it is not valid. And that's the idea. Now, logical contradiction, that's all falses. You don't have to have all falses for it not to be valid. All you just have to have is tautology. It's a true statement, meaning they're all truths. If they're not all truths, then it's not a valid argument. And that's basically the crux of truth tables right there. Like I said, we've got a few more examples that we can do, and we'll do those in class. 1, 2, we'll do both of those. And I have a few problems in the book you can take a look at. And otherwise, we will see you next time.